All right, so we are going to go over the review. Just so you know, I'm not going to write every single answer on here just for the sake of time, and so this video isn't 5 hours long, but I will say every answer, but I just may not write every single one of them down. The key is posted on Google Classroom, so if you do want those written answers, then you can check there. Now, for this first column, or actually, sorry, before that, know your vocabulary from the chapter. That's every chapter. Make sure you just know all the vocabulary. So for this chart, we have energy. Okay, so solid, liquid, and gas. Which one has the highest energy? Well, gas has the highest energy, so we're just going to draw an arrow right there. Liquid has the medium energy, so we're just going to do that. And a solid has the lowest energy. Okay, the more energy something has, the more likely it is to turn into a gas. As you heat up a liquid, it starts turning into a gas. So that means gases have more energy. As you heat up a solid, it starts turning into a liquid. So that means liquid has more energy than a solid. Okay. Spacing of particles. Solids have the lowest spacing of particles. They are the closest together. Liquids, again, have the middle spacing of particles. They are closer together than gases, but they are a little bit farther apart than solids. And gases have a lot of space in between. Sorry, I'm going to move this real quick. Okay, next, shape. So this is just going to be fixed or variable. Okay, so solid has a, and I'm not going to write this down, but solid has a fixed shape, meaning it does not take the shape of its container. Liquid has a variable shape, meaning it does take the shape of its container. Gas also has a variable shape, meaning it takes the shape of its container. Volume, same situation, fixed or variable. Again, solid has a fixed volume. That means it does not take up the space of its container. Liquid also has a fixed volume. Gas has a variable volume, meaning it takes up the entire space of its container. Compressibility. So compressibility just means something's ability to turn into a smaller thing or a bigger thing. Solids have no compressibility. Liquids have very little compressibility, and gases have a lot of compressibility. Okay, you can compress gases a lot. They have that kind of goes along with the variable volume over here. Since they have a variable volume, it's very easy to compress gases, whereas liquids and solids, it is not at all. All right, next, each of these is a property of one of the states of matter, and we're going to identify if it's solid, liquid, or gas, or more, multiple of them. So always occupies the entire space of its container. That is definitely a gas. Particles are fast moving with no attraction between them. That is also a gas. Particles are moving, but not spread far apart. These are a little bit goofy as far as the spacing goes, but particles are moving, but not very spread apart. So that would be a liquid and a solid. Liquids and solids are not very spread apart. Liquids do move more than solids, but that doesn't mean solids don't move at all. Okay, solids still move a little bit, just not very much. Okay. Particles have very low kinetic energy, so that goes back up to here with energy. Okay, so solids have the lowest kinetic energy. Has a definite volume, but not a definite shape. That's a liquid. And has a constant volume. That is a solid and a liquid. Okay. All right, so next is physical or chemical properties. Okay, now remember, a property is something that describes a substance. Okay, that is not a type of change it goes through. So physical properties or chemical properties, we're just going to do P or C. Color is a physical property. Okay, tendency to rust is a chemical property that is describing how something reacts with something else. It's describing how iron reacts with oxygen. Boiling point is a physical property. Any change of state or description of a change in state is a physical property. Density is also a physical property because density is a ratio between mass and volume. Mass and volume are both physical properties. Speaking of which, mass is a physical property. Ability to burn is a chemical property. Ability to burn is, again, a description of how something reacts with oxygen. Malleability is a physical property. If you don't know what malleability is, that is the official definition is ability to be pounded into a sheet. A little bit more layman's terms type of thing is ability to be molded into a shape. So like Play-Doh has a very high malleability. All right, so these are chemical or physical changes. Breaking a pencil, that would be a physical change because we are not making a new substance. We're just breaking the same substance in half, and now we have two of that same substance. Wood burning, anytime anything burns, that's going to be a chemical change. Silver tarnishing, that's the same as rust. So rust is a chemical process, as is tarnishing. Ice melting, that is just solid water turning to liquid water. So that's a physical property. Cooking an egg, cooking anything is going to be a chemical property. Okay. Grinding coffee beans, we're just taking some beans and turning them into smaller chunks, but they're not making a new substance. So that is a physical property. Burning gasoline, again, burning is always going to be a chemical property. So just a reminder, chemical change. I said property up here, but it should be chemical change, not property. But anyway, chemical changes are anything that changes the substance into a new substance or multiple new substances. Physical changes do not change the actual substance. You still have the same substance at the end of the change as you do at the beginning. All right, homogeneous mixture. Now, a homogeneous mixture is a mixture that is the same throughout the whole mixture. You cannot see the different parts of it. It is the same throughout the whole thing. So, for example, Kool-Aid is a homogeneous mixture. Kool-Aid is made of water, sugar, and Kool-Aid mix, but you can't see any of those individual parts. They all look like there's part of the same thing. So that would be a homogeneous mixture. Another term for a homogeneous mixture is a solution. Heterogeneous mixture is, as you would expect, the exact opposite of homogeneous. Heterogeneous is a mixture of things that are not the same throughout. So that means you can see the different parts of them. So, for example, a salad is a heterogeneous mixture because you can see the lettuce, you can see the cheese, you can see the tomatoes, you can see the salad dressing. You can see all those different parts of a salad. So that means the salad is a heterogeneous mixture. Most things in nature are generally heterogeneous mixtures. All right, so element, compound, heterogeneous, or homogeneous mixture. All right, now, to determine if something is an element, you just look on the periodic table of elements. If it's not on there, it's not an element. To determine if something is a mixture versus a compound is a little bit trickier. Generally, compounds have names like this one over here, calcium chloride. That is calcium, which is an element, and chloride, which is another element. Those are two elements bonded together, so that is a compound. Okay. Pretty much everything else is going to be some kind of mixture. And in that case, you just kind of picture what type of mixture, or picture the thing and determine, can you see the different parts of it or not? If you can, then it's going to be heterogeneous. If you can't, it's going to be homogeneous. Okay. So gasoline, that is a mixture. You cannot see the different parts. So that is a homogeneous mixture. Aluminum is on the periodic table of elements. So that's an element. Dirt, that is a mixture, and you generally can see the different parts of dirt, so that is hetero. Hand lotion is a mixture, and you cannot see the different parts of it, so that's HOMO. Baking soda is actually a compound. Granite, that's a mixture. And if you look at granite, the granite has lots of different colors in it. You can see the different parts. So that would be hetero. Gold is on the periodic table of elements. So that is an element. Chunky peanut butter is a mixture. And since it's chunky peanut butter, that means you can't, well, that's not how to write. Since you can see the chunks in the peanut butter, that is hetero. Now, if it was creamy peanut butter, that would be homo because you wouldn't be able to see the different parts. All right, next is aspirin. Aspirin is a drug, and that is the chemical name of the drug, so that is a compound. Oil and water. So oil and water separates with each other, so that is going to be a hetero mixture because you can see the different parts, the oil and the water separated. Wild bird seed, so that is definitely a heterogeneous mixture because you can see the different parts. We already talked about calcium fluoride as a compound. Okay, so 14 karat gold. If you were not aware, 14 karat gold is not pure gold. It is a mixture of gold, silver, and some other things depending on the place you get it from. But since you can't see those different parts, that is going to be a homogeneous mixture. Blood is a mixture, and you cannot see the different parts of it, so that is also a homogeneous mixture. Sucrose, so that is a scientific name for something, so that is going to be a compound. Helium in a balloon, that is an element because that is on the periodic table. Stainless steel is a mixture of iron and carbon, but you can't see the different parts. So, whoops. That is a homogeneous solution. Mercury in a thermometer. Mercury is on the periodic table of elements, so that is an element. Air, that's kind of a tricky one, right? Air is made of several things. It is made of oxygen, nitrogen, carbon dioxide, and trace other elements. Those are not bonded together, but you cannot see them, so that is going to be a homogeneous solution. Magnesium hydroxide, that's another, it has magnesium, that's one element. Hydroxide, that's a polyatomic ion, so that is going to be a compound. Moving, oh, that's it, okay.